All right, today, so we're going to talk about acids and bases. So, acids and bases are particular substances. Acids, we've talked about, start with an H, and bases, a lot of times, for basic rules for right now, end in OH. So, this comic, you can see, despite the heavy flak, McAllister's aim was true, and his carefully measured aliquot of hydrochloric acid found its mark deep in the enemy's reservoir of sodium hydroxide. McAllister grinned wryly. Finally, one of the enemy's strongest bases had been completely neutralized. So they're playing the joke here that acids can neutralize bases. And the word base versus a military base versus a chemical base. So, properties of acids, as we said, a lot of times you'll see an acid with a hydrogen ion right at the beginning. So they start with H. They have what's called a pH lower than 7, which we'll get to eventually. You probably have heard that. That's usually common in 6th, 7th, 8th grade science. They taste sour. This is why if you look at sour gummy guys or some of your sour candies, they have like a malonic acid or even citric acid from citrus fruits like oranges and grapefruits. Those have a sour taste to them. They have effects by indicators. For example, if you've ever heard of red cabbage, in reality, red cabbage is actually purple. But whenever you cook it, you usually add an acid to it, like vinegar, and that actually makes it red whenever it's delivered to the table. Blue litmus paper turns red when acids get there. If they are exposed to methyl orange, it turns red as well. Acids also react with metals. When an acid reacts with a metal, this is usually what you see, that bubbling, that hydrogen gas is produced. We did this with magnesium or zinc and hydrochloric acid last semester. That was the barking dog, or the one that goes boop and scares everybody. They also react with carbonates. For example, when we did the rates demonstrations, we had the piece of chalk. We put acid in there. Chalk is calcium carbonate, which caused that to actually bubble and again form that. Actually, that would have formed carbon dioxide. And as the comic said, acids will neutralize bases. So acids are proton donors. Strong acids are assumed to be 100% ionized, which means that they give all of the hydrogen positives that they can. These are the strong acids. Well, these are three of the strong acids: HCl, H2SO4, and HNO3. So that's hydrochloric, sulfuric, and nitric acid. You need to make sure that you have those memorized. Perchloric and hydrobromic acid are also strong acids, and hydroiodic as well. Weak acids usually ionize less than 5%, so they're poor. A weak acid would be like acetic acid, or what we call commonly vinegar. There's acetic acid. The first one is phosphoric acid. And then the organic acids, like citric acid. There's the other two. And third one. Weird. Yeah. Carbonic acid is the acid that you have in like sodas, like Coca-Cola and Mountain Dew. So this is the pH scale. It goes from, usually we talk about 0 to 14. At 7, that is neutral. Below 7 is an acid, and above 7 is a base. You can see some of the common things here, like your gastric fluid in your stomach has a pH a little bit higher than 1, so that's quite acidic. Carbonated beverages, 2.2. It is a pH scale, and basically what that means is it's a log function. Organic acids or weak acids, they're used as flavoring agents, like I said earlier, malonic acid or citric acid. These are, and even acetic acid would be considered an organic acid as well, vinegar. These taste sour. Malic acid is the one from sour apples. Lactic acid is the one that you find if you've ever let your milk go sour. Butyric acid is the rancid butter one. That smells like hot garbage puke, so it's not very pleasant. It's actually been used to basically get rid of protesters and stuff like that. Launch butyric acid at them. It's not very harmful. It just makes them smell bad. So the organic acids, we talk about the carboxyl group, the COOH, the COO, and basically that H that is right there, this H, it can come off, and that will increase the amount of hydrogen ions in solution. So they are very poor proton or hydrogen ion donors. And there's the litmus papers we talked about. Here's the blue one. It turns red. Red litmus paper would also stay red. And here you can say methyl orange has turned quite red from the addition of an acid. Here's the reactivity of metals with acids. So magnesium in HCl will make magnesium chloride and hydrogen gas. That hydrogen gas is the flammable gas. So we did one of these two reactions in the laboratory last semester. Both would form that hydrogen gas, which we tested for by using a flame splint. Carbonates, if we take a look here, this will form carbon dioxide. So that is the bubbling. The carbon dioxide comes from the CO3, which is the carbonate. Baking soda and vinegar is a popular one. Here is vinegar, here's baking soda. Boom. Calcium carbonate, the chalk or limestone type of thing. If we take a look here, here's George Washington back in the day. This is a statue outside in Washington, D.C. As industry created a more harmful rain atmosphere, which we call acidic rain or acid rain. We can see that over time. Poor George Washington. Every little crease in his artwork caused a trail for the acid rain to wash through, which started to take away the particles themselves, reacting with them. Acids neutralize bases, and they always produce a salt and water. So hydrochloric acid, which is strong, and sodium hydroxide, which is strong base, makes sodium chloride and water. Sulfuric acid and sodium hydroxide, well, it's a double displacement reaction. So you see the H comes in and makes HOH, which we reform as to H2O. And Na switches places with the H to make NaSO4, but to make the charges cancel, we need two NAs because SO4 has a -2 charge. One more here, we have HNO3 and MgOH2. Again, the H will go away with the OH to make H2O, and the magnesium with the 2+ charge will go away with the NO3, so we need two NO3s. And then obviously we need to balance it out to make sure everything works. Bases. So bases are proton acceptors. Basically they have a hydroxide ion. That hydroxide ion will add an H to it, or take an H and make H2O. They have a pH greater than 7. They taste bitter, like soap contains bases, and it tastes bitter. Hopefully you've never had to have your mouth washed out with soap. Bases affect indicators. For example, red litmus paper turns blue, blue litmus paper stays blue, and phenolphthalein turns purple or pink. Solutions of bases feel slippery versus solutions of acids feel just wet. And of course, as acids neutralize bases, bases neutralize acids. So we said that bases are proton acceptors. So if we take a look, sodium hydroxide, potassium hydroxide, magnesium hydroxide, calcium hydroxide, these are all strong bases. The hydroxide grabs hold of an H+ or a proton, a hydrogen ion, however you want to say it, they're all the same, and makes H2O. And that's how it neutralizes that acid. If the acid increases the H+ concentration, this OH negative comes in and starts to take it away. Again, here we have the bases that are below on the bottom half of this, 7 and above. The household lye, probably don't have a lye solution. Lye is used to make pretzels and cleaning. And also, she's been used by serial killers in the past to decompose bodies. Household bleach, probably have that. Ammonia is the main ingredient in glass cleaner. Milk of magnesia is like the stomach medicine. If you have sour stomach or your stomach feels like too acidic, you might take a Tums or a milk of magnesia. Baking soda also. And seawater is slightly basic. Blood is 7.4, so it's very close to neutral, but slightly basic. That's one thing. Your blood can't change from 7.4 too much, or bad things start happening very quickly. So here's the color you would see if a base touched a red piece of red litmus paper. That's that blue. I know you're like, that's not blue, but yeah, that's as blue as it would be. They always call it red and blue litmus paper. This is that purple, or as I call it, pink. This is the phenolphthalein. So there you go. Bright pink. Yeah. Bases neutralize acids. This is the milk of magnesia. This is the antacid, or also a laxative, but it contains magnesium hydroxide, which neutralizes the strong stomach acid HCl. And there's the formula for that. And again, how does it neutralize DH+? Well, it makes H2O. Excellent. Take a look at the next video to determine how to name acids and bases. Wonderful.